Okay, I think we can go on now. But before I call our speaker, I have a short bio here. Dr. Ralph Toon is currently a lecturer in the Department of Mathematics at the University of Ghana, Legon. His research interests are in representation theory and applications of homological methods in algebra and geometry. He's also interested in applications of topology to data analysis. I'm very sure to many of us, it will be a very, it will look like, oh, how can topology possibly be applied to data analysis? So the expert is in the house this evening. So could you please make welcome Dr. Ralph Toon from the University of Ghana, Legon. Thank you. You're welcome, Doctor.
Thank you very much, Dr. Danso. I'm really pleased to be here. Thank you, everybody, for coming. So I'll just start by sharing my screen, and then I'll go through some of the information I have. And I've been looking at the past BMA seminars, and I'm glad to see the discussions that have been going on, and I'm sure that people can, lots of people can contribute to what we will be discussing. And I've seen some of the questions in the chat. So as I go along, I'll try and address some of them. So as Dr. Danso said, I'm a lecturer in the Department of Mathematics here at the University of Ghana. I got into this usually trying to learn about Lie groups and Lie algebras, but we try and look at what is applicable and in the world today. And so what I'll do is I'll look at these courses. There are 5 subjects, and maybe let's look at what the learning outcomes of these courses are. Why do we do them in school? Why are they all in the undergraduate program? And then why are some of them in graduate programs? And then how do we apply them in technology? And then we'll open up for discussions. So let's start off with the learning outcomes, like I said. If you look at most undergraduate mathematics programs, I know some have completed undergraduates in mathematics, some are in graduate studies, some are PhD holders, and so on. And most of us, when we did mathematics or statistics, sometimes we combine with computer science. They will have several courses in the following subjects. In calculus, for instance, most of the universities will do calculus 1, 2, and 3, where in 3 in particular, you do calculus of several variables, and so on. So you do multivariable calculus. And linear algebra is standard. I have not seen a math program where linear algebra is not taught because of the need for linear algebra. And then when you look at statistics as well, and probability, there are lots of courses in there. Will be stuff on probability theory, probability distributions. And those who go into detail will do things like stochastic processes and so on. And then some will do experimental design. And then if there's a software or computational component, you will do things like R programming and so on. And then some programs would add a course in topology. Topology is more of a pure math course, but as we have seen, there are more applications, and we'll see how the applications work out. And then some may do some in geometry. But we are looking at these 5 subjects, and what are the reasons, or why is it that we have them in our programs? Why do we want students to take these? What are the skill sets that we want students to get when they take these programs? In particular, when you look at calculus, most of the time you will do things like differentiation, integration, but I'm looking at the goals themselves. So you want to discuss things like rates of change and applications, things of like drawing curve sketching, looking at things with related rates. And then also if you want to do integration then or differentiation, you want to look at simple optimization problems, maximizing things, minimizing things, whether you have constraints or you don't have constraints. And then sometimes with certain functions, it's easier to approximate the behavior of functions with polynomials. So you do linear approximation and so on. And these functions could be single variable like or multivariable functions. And then if you want, you would do an advanced calculus course as well. With linear algebra, everybody takes linear algebra. Both mathematics and non-mathematics students will take it because of the wide range of applications. We learn in linear algebra that vectors are not just the ones where you see in the plane or in space, but for instance, functions can be vectors or matrices can be vectors. And so you have a lot of objects that the methods of linear algebra can be applied to. And we try and visualize them in things like n-dimensional space or so on. And then we look at functions that transform vectors. And usually we will use the functions that transform these vectors. We represent them with matrices. And once you represent them with matrices, then you can talk about things like systems of linear equations, factorizing matrices, diagonalization, and then these funny things called eigenvalues and eigenvectors. And you see that in some cases you can apply them. For instance, if you think of what we call the ordinary least squares in regression analysis or in linear regression, it really is a linear algebra application. You are projecting your space onto another, where the other space you're projecting on are the descriptors. And then from there, you look at other machine learning methods like support vector machines or principal components analysis or matrix methods in terms of manipulation of images, filtering, and so on. So this is a very, very important course. And for linear algebra, if you're in any mathematics program as an undergraduate or even as a graduate, you usually will take it. Then the next three, statistics, there are lots of subjects, courses under statistics, but most of the time we're looking at methods of data collection. How do you then clean the data? How do you describe the data with different measures of central tendency or measures of dispersion? And then how do you perform tests on the data, hypothesis tests, and so on? And then later you get to regression, where you look at associations between the variables. And with probability, we're trying to look at the likelihood of events occurring. And if you want to go into detail, then you'd have to talk about things like probability measures, and then how do you create distributions? And you use that to model different scenarios. And for more advanced cases, you will look at derivatives pricing and so on, or quantities that vary stochastically. So then you have to look at things like stochastic differential equations. And so once you combine them, you can investigate what would be a fair price for a financial instrument. How do you break a financial instrument into the component parts, things like a stock, a bond, and then cash? And how do you interpret it? Okay, and the last one is a bit more out of the way. Topology. Topology really started as a pure mathematics course where you study shapes of spaces and you evaluate properties of these things which are preserved under continuous functions. So we have all these fancy things like connectedness, compactness, separation axioms, metric spaces, and it doesn't seem to have applications in the real world, let me put it that way. But as we have seen, the thing about mathematics is that no matter what you do, somebody comes around later and finds a way to apply them to all kinds of things. And here we're going to see a little bit about topological data analysis. So these are the 5 subjects we were given in the preamble. And what are the key things that we want to get from these programs? So once you take these subjects, as you learn the content, really what we want people to learn and what you are learning is thinking and communication skills. You realize that sometimes for the calculus and then for things like the topology and the linear algebra, there are lots of theorems that you think through and lots of proofs, but it helps you to think clearly about what you are writing. When you are writing out a solution, compose it or take ideas about it properly. So ideation becomes important and communicating your solution clearly. And then we would see that you need to be able to identify and model essential features of some complex situations. And then as you go through, if you've looked at some examples, how do you extract a general principle from particular examples? And then now as we go along, we see that we use a lot of technological tools. I mentioned one, we mentioned R. Now we're finding that R is being used a lot in statistics, sometimes in mathematics as well, and Python as well is also being used a lot in computational math and so on. And then the last part is also be data literate, and that is going to become very important in what I'll be saying next. You know how to use the basic statistical analytical techniques in analyzing data and then drawing inferences from the data. So these are the skill sets that we need, and these are the skill sets that will help us to succeed in the applications in tech that I will mention so far. I'll mention in the next few minutes. So now we've gone through what the content is about, and then what the skill sets are about. Let's now look at what next. Now, this is the meat of the presentation where we talk about how these are applied in the different technological areas. And a lot of the areas are now being influenced by, because of the computational power, things like artificial intelligence and machine learning. So AI and ML will permeate all of the things I will say. And so when you put all of these together, and those of you who grew up in the 90s will notice where the caption is from, but it's when you combine all the knowledge and skill sets from these, they provide a lot of opportunities in technology. So it's not enough to know one or two of them, but when you combine the powers, you are able to then see lots more applications. And so we'll look at some of the possible areas that we can use these skills. So there are lots. I wrote down a few that I could think of, and I'm not an expert in most of these, so I'm looking forward to discussions from you and in areas that we can apply this. So the first one, and obviously the current one, is artificial intelligence and machine learning. Lots and lots and lots of opportunities there, because there are lots of problems that were difficult to solve, but once you train an algorithm or you apply machine learning techniques, it takes you somewhere in the solution. And then, like we said, well, we're going to look at applications of topology to data analysis, so topological data analysis. And then there's financial technology. And then there are the traditional areas, computer science, software development, then insurance and actuarial science. And then green technologies and sustainability because of the issues of climate change. And then there's healthcare and epidemiology. These are not the only ones. And I said, I saw that it had a discussion on mathematics and biology and so on. So I'm very glad that is there. And I'm sure that impact from that discussion will help us as we go forward. So let's look at these in turn. The first one, like I said, is AI and machine learning. And if you take a good look at this diagram, this is from the World Economic Forum, the Future of Jobs Report 2023. They update it every year, and they're looking at the jobs that are going to grow in the next 4 years. And the top 10, you see that there's a lot of analysis in there. The first one is on artificial intelligence and machine learning specialists. So and because it's as you go along, these skill sets are added to your subject matter that you learn in school. There's a lot of demand for these specialists. And then there are those in sustainability. If you think of the sustainable development goals, we want to develop, but we want to develop in a sustainable manner. And people can help the organization or the country or the business develop in this manner are sought after. Then there's business intelligence, information security, and then there's financial technology engineers here, and then data analysts and scientists, big data specialists, and so on. So these are projected to be the top 10 growing. And then you can look at the top 10 declining, and you realize that almost all of these things can now be automated, or we can use AI to reduce the burden. And so we have to look at this as we plan and as we go forward and we look for employment. Okay, so with AI and machine learning, there are numerous applications of linear algebra statistics, data analysis, calculus to various AI and ML algorithms. I've written some of the algorithms there. Maybe in the discussion, we can look at what the details are. Again, I go back to the World Economic Forum, and they expect that a lot of the business operations will be influenced by machine learning and by artificial intelligence, whether it's the classic one of logistic regression or penalized regression, the lasso operator, or any of these things. In particular, the one that's more popular in the news now is these so-called large language models. I'm sure most people or some of you have tried ChatGPT-4, which is the latest ChatGPT given out by OpenAI. And if you try it, you realize that it sounds remarkably human. It's because a lot of work has gone into classifying them, classifying responses, and so on. And it can then do a lot of the low-hanging work for businesses. And later on, I'll mention a few of these, and I'll show you a few things I tried whilst I was waiting to join the Zoom call. So this is the one, if I was going to talk about the area you should be looking at where you could get the biggest bang for your buck, this is here. Because when you look at all the linear algebra techniques, like eigenvalues and eigenvectors, that's strictly going to be applied in principal component analysis. Principal component analysis is a way of reducing your data or trying to get the most important features of your data. So if you have a data set and you it's in many dimensions, there are many features, you can use eigenvalues and eigenvectors to break your data into eigenspaces. The eigenvalues are the principal components, and then the eigenvectors show you, well, which are the features that you take out. So again, if you take just the knowledge you have in linear algebra, you can do a lot of these. The same thing with support vector machines. You are classifying your data sometimes into two different areas or more. What you want to do is you want to get what we call a hyperplane that separates your data. And again, these are going to be usually data analysis, linear algebra techniques. Okay. So I'll move on to the topological data analysis. Now, topology is, again, like I said, the study of shapes of data or shapes that are invariant under continuous maps. One of the things you can do is develop what we call a signature, the signature of the space. And that actually brings some algebra into the topology. But without going into too much details, there are these two methods that we usually use to develop a signature of a space. One of them is homotopy, where you look at circles or loops in that space, and you analyze them and you put them into groups, and you see what is the nature of that group. The other one is what we call homology. And in homology, you sort of count the shapes in the space, where you look at, well, what are the components in the space? What are the bridges in the space? What are the loops in the space? What are the voids in the space? In other words, you are trying to count the different types of holes in the space. And there's a way to assign an algebraic object, which is a homology group, to each topological space in such a way that if two topological spaces, no matter whether they look different, they have the same homology groups, then they are the same. So how do we use that with data? Well, with data, one of the common methods is what we call persistent homology. So what we do is you've got your data points, and then you try and look at which points are closer to each other by changing the radius of the distance between them. And as the radius changes, if they are close to each other, you join them. And once you join them, you get a different shape. And then as you join them, you realize that you start now getting different shapes, different triangles, and different complexes, until you get to here, where now all of these data points are joined together, but then there's a hole in there. Here, all the data points are joined together, but there's a hole in there. And then here, all of them are joined, but the hole is gone. And then what we do is that we plot on what we call a persistence diagram, how the changes come in. So when they enter, so we call that birth. And then when they go out, so we call that death. And this creates a topological signature called a persistence diagram. The upshot of it is, if you have two data sets, or you have two data points from the same underlying data set, and they have the same persistence diagram, you can tell that they come from the same data point. An example could be, let's say you have a circle, and then you have data points like this. If you look at the persistence diagram you're going to get, they should be roughly the same. And that tells you that you can now look at the data, all of the data, extract the persistence diagram, and then use that as to get what are the features of the data, or how does the data set behave. So this is based on the concept that data has shape. And maybe in the Q&A, I'll give some sources, some introductory references to this material. There's actually now a Python module called Teaspoon that you can play around with and investigate these properties as you go along. So this is also becoming important. There's now lots of work on this in machine learning. There's also another paper on introduction to topological machine learning, which I can share, so that if you're interested, you can look through and see what the possible applications are. Okay, then we move on to financial technology. The applications here are going to try and simplify and automate several aspects of different banking and financial transactions. And you find out that, again, the knowledge you get from our subjects are applied in these, in blockchain technology, for instance, where you are trying to decentralize the transactions. So, and then cryptocurrency applications, which is going to be built on different kinds of blockchain technology. Fraud detection, here we want to automate it, so you would use particularly AI and machine learning approaches. You can work on trade and investing platforms, things like Robinhood. I'm sure some of you might have heard of it. And then also chatbots. Again, there are chatbots that can use different algorithms to advise prospective investors on different investments that they could use without them having to talk to a financial advisor. So this is becoming also a big role. Obviously, you have to then train the chatbot to understand the instruments and then be able to offer the right product for the client. But in that case, again, that means that you have to learn the mathematics, the finance, and then you put that together with the data science. Okay. Now, the so-called traditional computer science disciplines are also a good place to look at. Basic software engineering, algorithm design and development, operations research, and information security and cybersecurity. The difference now is that these disciplines are now being infused with techniques from artificial intelligence and machine learning. So it's not just writing programs or writing specific programs to solve a problem, but now you're applying the machine learning, not explicitly programming the software to solve different problems. And so there's also a great need for people who are skilled in these areas to come into that part of the industry. Okay. Now, insurance and actuarial science as well, you find that there's now an increasing use of AI and machine learning techniques in the actuarial field. So even as you take the exams and you learn about life contingencies, things like loss models and so on, you find that now there's more use of these techniques in the actuarial field. I was looking at a paper this afternoon where the prize-winning paper, so the the Society of Actuaries has a journal called the North American Actuarial Journal. And the paper actually showed how you could use things like a classification and regression tree in pricing a policy, or so a classification and regression tree essentially asks a series of questions, and depending on the answers you get, it bins the policyholder, in this case, in a particular area, and then you can then use that to price the policy. And it actually shows how technology can be used to develop different ways to price an insurance policy so that the policyholder benefits and the insurance company does not lose. So there's a lot more now coming to change the way we do things like insurance, actuarial science, or predictive analysis. Okay. Now, because of climate change, we need to make sure we understand climate data, update our climate models. And so you find out that we're going to be needing a lot more people to be able to build, understand climate models, whether they are using differential equations or some kind of stochastic model.
Oh, so sorry about that. We lost connection with him. So okay.
I think I'm back. I don't know what happened.
Okay.
Let me
Sorry.
continue. Apologies.
Excellent.
Apologies. Okay, so I was talking about sustainability, and so that's the infographic there is from the Sustainable Development Goals, and I believe that we will need to build models to help in all of these areas. When I talked about the increasing jobs, we talked about sustainability engineers and so on. And so we need to be able to help to find ways to sustainably use resources, particularly where now extraction is difficult or environmentally destructive. In Ghana, for instance, we have a big problem with people mining for gold in all kinds of ways and then polluting the rivers. So we are going to need more scientists, more mathematicians, more statisticians who can help, first of all, to look at ways in which we can reverse the damage that's been done, but also then to going forward, how do we do these things in a sustainable manner? And so this is going to be bigger. I'm not an expert in green technology. I'm hoping that somebody in the audience can tell us a bit about what they do, and that would inform us all. Okay. So I just added, this was from the World Economic Forum again, expected impact of trends. There is going to be, going forward, we will need to factor in sustainability in our operations. Okay. Then healthcare and epidemiology. I won't say too much. I know you've had a seminar on that, but again, we use that in disease modeling. So whether it's differential equations or stochastic processes. But the key thing is last year, Google DeepMind predicted the structure of millions of protein molecules. And so basically, you're able to predict a protein's 3D structure from its amino acids. And the reason why these are important is that if we have the structure for these protein molecules and so on, it may help us for new treatments for neglected diseases, neglected tropical diseases in the coming years. So this is big news. This was last year. And so it then shortens the time to development for drug discovery and drug development. And so again, AI and machine learning techniques are leading to lots of insights into biology and disease modeling. And these are going to be, there are going to be more and more of these coming up as we go along. This infographic is from the DeepMind website, where they actually looking at, when they talk about how they did it, and then the database where you can actually go and see some of these protein molecules or the expected structure of these protein molecules for yourself. Okay, so I have a couple more. Oh, I don't actually. So I will end here, and then I will be around. I'll look in the chats, and then as time goes on, if there are any questions, I'll be happy to answer. Thank you very much.
Yeah, the question sessions are coming up immediately, so so we don't keep you waiting for too long. I mean, that's a has been a very insightful talk. I mean, it's so interesting that you actually, sincerely, you beat my expectation with your presentation. So, I'm sure a lot of people have questions already. So if you can speak, you can just unmute yourself and ask your question. Or if you don't want to speak, you can just type your question in the chat. So please feel free. We've had a great talk from Dr. Ralph Toom, and it is time to ask your question. So if you have a question, feel very free to do that now. There's a question here. Okay, thanks. Somebody's thanking for the discussion. I'm thanking you to it. BMA thanks you for that very deep talk. We like that a lot. So any questions in the house, or are you reserving it for later? Yeah, I'm sure somebody has a question for sure.
Hello, everyone. Thank you very much, Dr. Ralph. Thank you
great.
very much, Dr. Dance, and the other coordinators for this. Please, maybe it's kind of a request. Would it be possible to share your presentation material slide, because it's delved deep into the applications of various areas, maybe a question that most of us that had mathematics as our undergraduate course never really knew. We just had to take some classes because we needed to take the classes and pass the exams, not necessarily knowing how important, especially in the field of topology. Now I'm seeing someone doing something on topological data analysis, and from the figures you presented, since my research interest is more on networks, graph networks, so seeing some kind of I was able to visualize some kind of network structures from what you did there, and I could maybe see kind of connection between network topologies and maybe what you're doing in topological data science. So if you could be willing to share your slides, I don't know, with the coordinators, so they could forward to us via email, since they practically have the email account of those that registered for this program. That would be really helpful. Thank you once again for a very insightful presentation.
Yeah, most welcome. In fact, I'm going to email the slides right now. And so let me do that as I hang on. So
that is highly appreciated.
I'll do that. Okay.
Yeah. All right. Do we have any other questions, please? I mean, that's so interesting. Any other questions? Okay. Okay. If you have questions, please gather them. Thank you very much. So how can a graduate without the knowledge of computational analysis start up? Okay, doctor, you want to answer that?
Okay, well, I think that again, I remember when I was a graduate student, somebody said, well, we cannot teach you the mathematics, but we can teach you the other things. Once you have the mathematics background, you start picking up with the computational. It's always good to take a language that is straightforward. I'm biased to Python. I know other people are.
Me too.
So because it's very, very, very straightforward to learn. I would say you start off with get something you are interested in doing, and then you see how you can use Python to do it, and you find that you pick up the language quite well. Say you want to try and learn or analyze some data, and then you see how you can use Python and pandas and so on. And you before you realize that you have picked up the language, you know where to go for help, and then you go on from there. So that would be my advice in that case. And you're at the right place in the sense where these things are going to be more and more important as you go along. So you are not late, you can continue.
Yes, thank you so much for that great answer, Doc. I have space for one more question if there's a question again before we move on. Of course, just like you've been told already, the number one job for the future is AI and machine learning. And as a mathematician, you are seriously positioned for that. I hope you know that the word artificial intelligence was coined in 1954 or something in a program that happened at Dartmouth University by some mathematicians like James McCarthy and the rest of them. And some of the pioneers, in fact, when you talk about computer science, the pioneers are mathematicians, and then artificial intelligence, same thing. So as a mathematician, you have a very strong background to really move into these things. So, I mean, that's the essence of the things we do. Okay, 1956. Thank you so much for that. Okay, so at this point, I have a very difficult task of being both moderator and presenter. I'm not supposed to be the presenter, right? But something came up. Grace Olainka, who is supposed to be our second presenter, could not show up. So I'm going to read her bio. She's won person who has really she studied math. She was my student in FUTA, and she started learning coding in 100 level, and she was just playing with those things. She didn't even know there'll be a future for her in it. And along the line, I mean, everything just blew up, and she's doing great as a tech person right now. So I'm going to read. Okay, somebody's still asking, what about someone who doesn't have knowledge on Python? Go and learn Python. You have everything you need to learn Python. So just go online and search for, or just go to learnpython.org and you can just start right away. Okay, so let me read Gracie's bio, then I'll do her presentation. I wanted somebody else to do it, but the person was not available. So I must apologize that you have somebody on our flyer and she's not available. Sorry. It was not expected, but here we are. So, but we have to move on. So, Grace Olayinka is our next presenter. Let me see which of the bios. Okay, let me go for the summarized one so I don't keep you waiting for too long. She sent me two versions. She sent me the long one and the short one, but I think the short one will do in this case. So Grace Olayinka is a Bachelor of Technology graduate of Mathematics from the Federal University of Technology, Akure, Nigeria. She has over 6 years of experience as a blockchain app developer, trainer, mentor, writer, and keynote speaker in events related to blockchain, NFTs, Web3, front-end development, and career growth. Grace has mentored over 10 people in their tech careers and personally trained over 1,500 people in partnership with various organizations. She has authored 2 ebooks on Web3 and 1 hard copy book on career growth in tech. Grace is currently the tech lead at Neo Group, empowering Black women in tech globally, and has won awards for her contributions to technology. So maybe this is something the leadership of BMA wants to look into. We have a group called the Neo Group that are empowering Black women in tech. So we may want to think about a partnership with them in the future. So I apologize that you have to keep seeing my face, even when the presentation starts. That's not our plan, but that is where we are at now. So let me try to share her slide. So I hope it won't be awkward having to, I don't know how we talk about it. Okay, let's see how the thing goes. Okay, let me try to share. Yes, there you have it. And let me go slideshow from beginning. Okay, so as we know, what we are considering is math in tech, applications of linear algebra, topology, calculus, probability, and statistics in tech. Okay, let me not talk like I'm the one presenting. I'm the one. Okay, let me talk like it's Grace presenting as much as possible. So I mean, this is Grace's story. Okay, just visualize that I am Grace. So let me I don't have to deal with that conflict of me not being her, right? I studied mathematics in FUTA. I am glad I did because math is about solving problems. So is tech. So I mean, math and tech, they have a common thing, and that is the fact that they are both out there to solve problems. So math is for solving problems, tech is for solving problems, and it is so cool that you can come together, right? Currently, a tech lead at Neo leading a number of tech experts. Some major areas I've used my statistical knowledge has been in data analysis during my IT, that's industrial training. It's funny how I'm currently working on a 3D modeling project, and linear algebra has really helped. Okay, so my team and I had to do some maths, and that's very interesting. So mathematics has also helped me when I was teaching the primary school students of Water Spring International Akure about robotics. So okay, I'm talking like Grace, right? So they were also able to relate better because of their elementary math knowledge. So having, even for, I think this is a high school in Akure, where she had to teach them some basics about robotics, and the fact that they already understood some mathematics was really helpful for them to understand. And then the introduction. So mathematics is the backbone of technological advancement. I think we've said that much, enabling us to harness the power of data and develop innovative solutions. It provides the foundation for solving complex problems, analyzing data, and optimizing systems. Okay. I believe it also aids fast thinking. Your brain is always in providing solution mode. So, okay, yeah, I think let me just allow myself. Now, there are many times you're teaching in class and students ask you, sir, what is the application of this thing? And I think, of course, apart from the fact that these things actually have real applications in technology as we are concerned about, but the fact that you have to think up solutions to even problems that people will not normally think have no solutions. It has a way of wiring your brain to be ready, to always be ready. So as a mathematician, as you are seeing something, as people are dancing around, you are seeing solutions to the problem they're all worrying about. Okay, so she talks first about application of linear algebra. And so she said data analysis and machine learning enables us to manipulate and analyze large data sets efficiently. Now, you in linear algebra, right? One of the key things in linear algebra is the idea of matrices, right? And it is in rows and columns. Interestingly, you can hardly carry out any data analysis without most data sets you have are actually in rows and columns, and that is linear algebra right there for you, right? So, and because of this, it helps us to manipulate and analyze large data sets efficiently because as you arrange them in rows and columns, they have addresses and you can actually deal with them like that. So, another application of linear algebra would be computer graphics and image processing. And this helps us to represent and manipulate geometric transformations such as rotations and translations. Applications include 3D modeling, rendering, image filtering, and image compression. So if you have to work with images, basically, and for people who have done some in-depth work on using MATLAB or even Python, right? I think for something like Pygame is for gamers, for those who develop game applications. So there you have to work with a lot of motion graphics and things like that. And linear algebra plays a very huge role in this stead. So if you are into photography, for instance, and you're a mathematician, begin to think of the connections between these things. So there's also cryptography, right, which is also very essential these days. Cryptography and network analysis. Thank God just talked about network analysis just now, which is our area of research. Cryptography and network analysis are used for encryption algorithms, network routing, and error correction codes. And cryptography is also used in blockchain. Now, blockchain is becoming the big thing, right? Such that, of course, the most popular one we know is cryptocurrency, talking about things like Bitcoin and the rest of them. But that's just one application of blockchain. Blockchain can be it's the whole idea, just like Dr. Raf also already told us, is the idea of decentralizing your operations, your transactions, be it financial transactions or even in governance, blockchain technology can be applied here. And since you're decentralizing stuff, security is very important. And that leads us to cryptography. So you can't do cryptography without linear algebra, right? So that's one thing we see here. And then, of course, we talk about the application of calculus. So algorithm development and optimization, it helps us find solutions and improve efficiency. Now, even in coding, right? In writing codes, okay, for instance, today I was teaching a Python class and so am I Grace now? Okay, just enjoy. Today I was teaching a Python class and at first we had a code for something like a Cartesian product and we had 41 lines of code and we were just thinking of ways of minimizing that. So at the first attempt, we were able to reduce the lines of code to like 33. Then afterwards, we're able to reduce it to 28. That is to tell you that the codes you can write in 50 lines could that's probably even be written in 20 lines, and you get exactly the same result or even better, right? So, and when you talk about algorithm development and optimization, that's making the most of little. So it helps us find solutions and improve efficiency. So you can write a code in 50 lines, that's good. Or you can also write the same code in 28 lines so you save space, you save computing power and things like that as much as possible. So we can apply this in optimization algorithms, machine learning, and data analysis. So one key thing in optimization, for instance, is the idea of derivative, right? Of course, there's also non-derivative optimization, non-differential optimization. There's something like that. But the bulk of optimization is actually, dependent on calculus because it's all about derivatives. It's all about, when you talk about this gradient descent and things like that, they are basically calculus things. And of course, when you go to robotics and control systems, this helps to model and control the movement of robots and other automated systems. So, it's about motion and motion is about change, right? So one of the things in robotics, for instance, is the idea of planning that, you want to program the robot in such a way that it is ready. So when there's an obstruction, if you go to places where robots serve food, like in Japan or other places, so you find out that if you want to think the robot is not smart, try to work in its way. It probably stand aside for you, or just find its way around you, and not hitting coming. I mean, not don't be an accident, right? Because all of that has been programmed into it, that if you sense something within this distance, you should move. So all of this, and because these things happen, these are changes, right? And calculus basically captures that idea of change. And of course, we talk about Dr. Thomas talked a lot about this, about economics and financial analysis. Talking about actuarial science and financial transactions and the rest of them. So calculus actually helps to analyze and predict market trends and optimize investment strategies. It can be used for risk assessment also. There's this idea called hedging in in finance, right? It's the idea that whatever happens, you not run at a loss. And we saw that kind of example as raised by Dr. Tom in his presentation. Now we talk about applications of probability and statistics. So I don't know what A/B would be. A/B testing and optimization. It helps us evaluate and compare different options to optimize outcomes. And it can be used for website testing, marketing campaign analysis. Of course, she's a website person. She does some UI UX stuff. So I think she probably would have been able to explain this better. So in this case, probability and statistics can actually be used to to look at these things, to test website marketing campaign analysis. So you want to see what are the chances that maybe something you're bringing on the market is going to actually have the impact that is intended. And of course, talk about simulation and modeling. It helps with simulating complex systems and analyze their behavior. Things like weather forecast is a popular example. In some places, weather forecasting it comes with that, like in Japan, right? Weather forecasting comes with that level of precision. You are leaving your house in the morning, and probably because you are not used to checking weather forecast, you just say, it's so sunny and hot, and you see everybody carrying umbrella, and you're wondering what is happening. And then you check maybe you now try to check the weather forecast, and you discover that, oh, it's going to rain at 2 o'clock with 80% with 80% possibility, and then it's 2 o'clock, and then it starts pouring all over the place. So I mean, all of these ideas have been harnessed to such a large extent to actually help us live better. Okay, wow. Okay, I think it's shorter than I would have expected. These mathematical aspects are vital in developing AI algorithms, training models, handling data, and making intelligent decisions. So AI is the most popular sector that people believe math is mostly used. I am sure we know now. We now know other sectors, right? But of course, I mean, it's if AI is all you've heard already that is the future. The future of works is all about AI and machine learning. So, as a mathematician, one thing you are living here with is stats, and of course, just like Dr. Tum, I'm biased towards Python. Of course, interestingly, I was having a discussion with somebody last week who actually, in trying to venture into data science, he learned R and probably Power BI. Of course, R is great, and it's especially, I think, like currently I work in an ecological lab, and I think the main thing they use is R, right? But of course, if you really want to go into industry, of course, there's this ongoing debate. But for me, as far as my discussion with that person was concerned, after learning R and everything, getting a job, I mean, has not been that easy for him. I felt confident that if it was Python he learned, he would have probably been able to do more. Because with Python is not limited, right? With Python, you can go into scientific computing, you can do data science, you can do machine learning, you can do web design, you can do gaming and things like that. So it's so vast that what you want from it. If somebody comes to me wanting to learn Python, the question I ask is, what exactly do you want to do with it? Because it is so vast that you can use it for whatever it is you want to use it for. So of course, AI is one predominant part where we have applications of math, but of course you can find the application in many other areas. So I believe math is a strong foundation for most technology career paths. So if you find yourself in math course, please do not be discouraged. You can maximize it and take up a skill in tech. I think I know where she's coming from. Many people come into the math department in FUTA, for instance, they come because they actually wanted to study electrical engineering or something, and then they were just pushed into mathematics, and they come sulking. And then so I've seen people over the years and they're like, oh wow, one of the biggest things that happened to me was the fact that I studied maths, because with a maths background, you can now venture into different things. I know mathematicians today, they are doing excellently in the financial sector, in even in biology. Like right now, I work in an ecological lab, for instance. So with a math background like that, it's like you have what it takes to go wherever you want to go. So if you have questions, this is the time for questions. All right. So, and since I mean, it's time for questions. So feel very free if you have any question. If you have, the Dr. Toom is still around. If you have questions for him, to feel very free to come up with those questions. So anybody? Okay, I think there are some charts. I hope. Okay, please, can you briefly talk on transition from optimization to data science? Okay, I think I give Dr. Toom the first opportunity, since I am not Grace. So I mean, just go ahead. I mean, you have the opportunity since you're around. I mean, feel free.
Okay. I mean, okay. So when I think of optimization, I think about finding maybe maximum or minimum. I wrote down one of the things called lasso, and lasso is a kind of regression analysis where if you add too many explanatory variables, it penalizes you or it penalizes the model. So in other words, you want to explain something or you want to classify something, but you want to use the minimum amount of explanatory variables. So lasso is, I think, least absolute shrinkage selection operator, something of that sort. So again, you don't want all of the features in the data. You want the best ones that give you the best, the most or performs best given the amount of features that you want. Otherwise, the model is too big, and then it will classify everything and then not work well. So again, you find out that yes, you have the regression, the statistics, the linear algebra, but you also have the optimization. So we develop a function that penalizes it, and you want the one that gives you the minimum value. So that's an example of an application.
Like the direct. Okay. Interestingly, just before this event, I just okay, I finished the class and I was just I wanted to know about regression. I began to see things like lasso. So it's so interesting to hear Dr. Toom talking about it. There's another thing here. This is from Anas Usman. He or she says, hello, thank you for the presentation. Please, if I want to move into topological data analysis, where would I start? I mean, the resources I need. Thank you once again. So please, Dr. Toom, you're on the spot. Sorry.
That's fine.
Yeah.
I think I'll send some resources out as well. There are some introductory papers on it. So there's one by a lady called Elizabeth Munch. She's I think one of the ones who developed the Python module, the teaspoon module. But there's a very nice paper on it. And there are now, the earliest textbooks came out in I think 2010. So there are 2 books out on what they call computational homology, but I'll give out some resources on just the introduction so that you can start from there.
What's the link to go learn Python? Okay, Dr. Ralph, thanks a lot for putting. If I learn Python.org was my first call, and that was really helpful. And one thing I've discovered about learning programming, when I started out, I started by watching videos. You see all the 6-hour videos, 12-hour videos. But at the end of the day, when it is time to implement, it's so you just lose interest. I mean, that was at least what happened to me. But going to learn Python.org, for instance, you have a real code, you implement it, it works, then you can copy it out onto your space and try to tweak it and see what happens as you tweak. So, and from there, I just discovered that the best way to learn programming is to program, right? You see a program, run it. If it works, then take it and begin to play with it, change things, see how that works. And before you know it, you're getting a lot. Okay. 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 Chisom, thanks for that. This is so inspiring. I'm glad I joined. So please, if you want to talk, feel free. This program is scheduled for, okay, if not because of time factor, I would have loved to see an example on thesis application, on these applications, that is to solve a problem using this mathematical concept. I don't know if Dr. Toom is readily available to take care of some of this.
Well, we could try, but maybe not immediately.
Oh, okay, no pressure.
Yeah, so we'll come back in. I just want to say I've sent you the slides by email, so later you can share with them.
Yes, okay. I'll do that. Yes. Okay. Super well done for your educative presentation. Just trying to see the other questions. I'm highly interested in application of linear algebra into data science. How can I start off? Okay. What about someone who doesn't have knowledge on Python? Okay. So, I mean, these are two talks. What about someone who doesn't have knowledge on Python? And then I'm highly interested in application of linear algebra into data science. How can I start off? Well, I think I'll go, I'll give Dr. Ralph the opportunity again. Like,
Oh, okay. So with the Python, like we've discussed, there are lots of resources because it's a very popular language. It does it can do a lot. First of all, it's a programming language. So anything that you can do in the others, it can do. But it's also very highly tuned for data analysis, for machine learning, for regression. There are lots of packages. There's scikit-learn, which has lots of the implementations of the machine learning algorithms. So you can try your hands on it. And then it's freely available. Even if you don't have it on your computer, there's what's called Google Colab, which you can try with a full suite of Python applications. Now, with the application of linear algebra in data science, I would say things like, if you've done any course that uses things like eigenvalues and eigenvectors, go and look up what PCA is. And you can look at PCA in finance, for instance, in how you use PCA in portfolio theory. You will see that they're taking the things you do where you find the eigenvalues and eigenvectors of a matrix, and now we're applying it to finance. And so if you've done linear algebra up to eigenvalues and eigenvectors, then what you need to do is just start looking at the applications. I think that in the other presentation, there were things on network analysis and so on. You will see that then they start coming out in that area. And that's what I can say.
Okay. Patience Evans says, thanks for the presentation. Can we send our email for the presentation and material? Now, if you registered, if you got your link through your email, we already have your email. If you registered for this event, we already have your email. So you're going to get the presentation for sure. So as an aspiring data scientist, knowing things that are expected of me in the application of mathematics.
I registered today. I did not receive the link. I only received it from the WhatsApp group.
Oh, okay. I'm very sorry for that. So what I'm going to do is I'm going to share our email address, Black in Maths email address. I'll share it in the group now. So for those of you who could not, who have not been contacted in one way or the other, you're going to put your, in fact, I think I want to encourage everyone to put their information there because we are thinking of giving certificates to everybody in attendance. I think right now we have 37. Okay, let me quickly type that in. That's our, so if you attended this and you need a certificate, I know it's not necessary, everybody may not be interested in that. If you need a certificate for this event, so you can just send us an email. So we want to do it this way. We don't want to send it to everybody who registered because everybody who registered does not is the fact that someone registered does not mean that they are present here. So we want to strictly give it to those who are in attendance. So blackinmathematics@gmail.com, that's the email. So just send us an email, tell us you attended this event, and we'll send you a set. So tell us the way you want your name to appear. If you want your title to appear and things like that, just put it the way it should be. Somebody said, "Is there a WhatsApp group for Black in Maths Association?" Yes, we have a channel, a Telegram group for Black in Maths. So I don't know if Dr. Neka is here or Dr. Adejimi. You can quickly share the link to the Telegram group in the chat. So from there you can easily join. So there a lot is going on. There we share opportunities about scholarships and things like that. Okay, I think one easy answer to most of the questions about learning anything. So these days, with the advent of AI tools like ChatGPT, Google Bard, and Binge, you don't have any excuse not to learn anything again. Interestingly, of course, the thing is you need to know the basics of some of these things. And once you know the basics, you can advance your goal. And since we still have a bit of time, I want to quickly show how you can use especially ChatGPT to your advantage. For instance, somebody here is saying that what if you don't have knowledge of Python? Well, in that case, all you need is go to learnpython.org and try your hands on those things. And once you have done that, then ChatGPT can take over from there as your teacher. Okay, now can you see ChatGPT displayed here right now? So I'm sharing. Can everybody see this? Hello?
Yes.
Okay, good. So, I mean, you are new to, let's assume you are new to Python. So you can just ask, guide for Python beginner. Let me something rough like that. Guide for Python beginner, right? And there to just give you that, so it tells you, okay, install Python, choose an integrated development, whatever, learn the basics, practice writing code, explore Python libraries, join a community, work on small projects, read code and documentation, embrace debugging, keep learning and experimenting. Of course, I know you're not going to have it easy at first, right? So that's why I still recommend going to some, okay, you can go to python.org and just try coding first. Then you can, just like you've been told, you can use Google Colab as your IDE. That's one easy one. You don't have to install anything, just open it. Once you have a Google account, or maybe if you don't even have a Google account, just once you have an email address, just open Google Colab, and any code you see in learnpython.org, once it runs, copy it, paste it there, and then there you go. Then so as doctor was talking, I had to quickly go and check up on the topological data analysis because I found it very fascinating. And okay, like now you've heard about topological data analysis. I've been hearing about it, but I never bothered to check it, right? Just check topological data analysis, right? And boom, it just tells me what it is about and how you can, just tells you some stories. The persistence thing it told us about and everything, all of these are coming out. In fact, you can even say, if you already know some Python, right? I even ask, okay, implement topological data analysis with Python, right? Implement data analysis with Python. So it gives you codes, right? It installs the stuff and gives you the necessary codes. Yeah, then it starts giving you. So, this is probably an example of a random data set. So if you now have a real data set, then you can so once you understand this, if you have a real data set, just import it and you're good to go. So that's why I said you don't have any excuse to learn anything, whatever it is you want to learn. Now, with this, now maybe you already use R and you want to migrate to Python. So all your R code, if you copy your R code, it can convert it to Python code. Of course, sometimes it will have errors, right? And that's also the place of having understanding. So you can convert your MATLAB code or Python or R code to Python and implement. So of course there'll be bugs, right? That's why it is necessary you have a background already, so you can know if there's an error, you know how to do it. In fact, you can even use this to debug too. You can, if you're running the program and it's giving you a headache, you don't have to spend all day. Just bring it here. Then, in fact, if you just copy and paste and run and enter alone, it will already look at it that, okay, this code is not correct. There's something wrong, and then it corrects it for you. You copy it and take it back, and you implement, and you're good to go. So, if you are a BMA person and you are currently seasoned, you have no excuse about learning whatever. I don't even care what it is, whether it is Python or even R. Of course, I know in some cases you may have to use some particular tool, by all means. So you have that. And then maybe I should also use this opportunity, for researchers, right? Most times, somebody is disturbing us. Let me see. Shush. Okay. So, and one issue we may have with something like ChatGPT is that it doesn't give you references, right? And now these days, if I want to do my literature review, I don't even waste my time. Normally what I would usually do is I'll just I'll go on Google and type a keyword and to give me a number of papers, and I start downloading. At the end of the day, maybe I don't even need most of the papers. So, and that takes me to the idea. Okay, let me stop sharing. So, I've introduced you to ChatGPT, so you can write codes, you can do all of that with it. But when it comes to research, I now need real research papers, right? You can actually use Binge. So I did, of course, Microsoft has a way of boring you normally, but with Binge now they have won my heart. So because the edge Binge has is that you can get actual actual papers. You can get actual papers when you ask for something. Okay, so let me try to share this now. Okay, let me try to share this. So please, if you still have questions or you have a contribution, we still have a bit of time. So let's see if we can take your question. So where is, okay, yes, let me share. Okay, so this is how the binge interface looks like. This is the binge, that thing that looks like B, right? So here now, you've heard about topological data analysis. So what would you like to chat about? What's happening? Why is it not answering? What's wrong? Okay. This is actually coming to. Is it here? Topological data analysis. Okay, no, that's not what I want actually. Well, that is still more like Googling something. So I really wanted to talk about this and give me some papers to that effect. Or is it okay? That one was blocking it. Good. So if you type it here, for instance, the one I did at first is just like you're Googling normally. So, but with this now, this is Binge itself, Google topological data analysis, right? So if you type this, it will give you information. It won't talk plenty like ChatGPT, but it will give you papers you can cite, like even recent papers, most likely. Okay, it gives Wikipedia, right? Okay, now it's okay, good. So you can already see this frontiers most likely is a paper you can download that will be in PDF, like a citable material. Good. In fact, it's a paper by Frederick Chazal and Bertrand Mitchell, An Introduction to Topological Data Analysis, Fundamental Practical Aspects for Data Scientists. Can you even imagine? So I can download this and share it in the group immediately. All right. So you have everything you need these days. So you don't have any excuse not being able to learn something. So I think I want to stop here because this is not the purpose of this meeting. So I mean, you have all the tools. There's also Google Bard, BARD. Oh, I thought I was downloading this already. Oh, okay, it's downloaded already. Good. So if there are no questions or are there, okay, let me check the chat box before I go. Okay, let me stop sharing. Stop sharing. Yeah, so let me check the chat again. Okay. Yes, the link to, thank you very much, Dr. Nick Ihionu. This is, so she has sent us the link to the Telegram group. So just click it and you're part of the Telegram group already and you enjoy all the benefits. I'll be very grateful if you can also share this recording with us. Yes, if you registered for this event, you have the, you're going to get the recording. In fact, we have a YouTube channel which you can sign up to immediately. It's just Black in Maths Association. So you can subscribe and click on the bell. So once a video is uploaded, you see it. So and of course, I think the link will be sent to you. So I'll be very grateful if you can also share this. Okay, I think I've taken care of that. Okay, that's the Telegram. That's the Telegram link. So you can just click on it. Yes. So at this point, if you have anything to still say, go ahead. So we can call it a wrap already. I think you will agree with me that it's been a very nice time hanging out here, talking about these things. And do you want to say special thank you to Dr. Twum? Just say something in the chat box. Appreciate him. We are very glad. We wish we can really pay you for this, but we have a little certificate for you, which we'll send right after now. So the Telegram link is already there. So please just scroll up. It's shared by Dr. Nneka Ihionu. So you'll find it there. Yeah, this is it right here. Yes. So, okay, if there's no other thing, I think we can call it a wrap. So once more, Dr. Tom, do you have a final word for us before we go?
I just say thanks for coming. And the future is very bright, particularly for African mathematicians. If we continue pursuing this, there are lots of problems we can attempt solving. We'll get solutions to most of them. Right. And for those who are interested in more advanced aspects of mathematics, there's also work there as well. So thank you very much.
Thank you very much. We are very grateful to have you around. Patience Evans, you have a question? Okay.
Yes, sir.
Okay, nice. Please go ahead.
I have somebody that got admission into mathematics but rejected. Admission into mathematics.
Okay.
To read mathematics, but he
Okay.
rejected it because he felt he wants to do robotic mechatronics. So
That's
how
interesting.
do we connect there? Because when you were saying something, you said we can connect it with the robot and all that. So how do we connect it? And I want to convince him to read the mathematics.
Yeah, I mean, in fact, do you know what I started advising people when for instance, of course, because of the kind of way mathematics has been presented to us, we see it as one difficult course and everything. For instance, when I was leaving secondary school, right, I loved math, right? But I couldn't imagine myself studying math because it would be like once you study math, you have to be a teacher, maybe a secondary school teacher for that matter. But then because I liked math, so I ended up studying engineering. But thank God I did not do a bachelor's degree in engineering. I just did a diploma in marine engineering. Find out the grades were coming out, but then I wasn't really having a nice time. I wasn't enjoying the whole engineering thing. So after diploma, I went in for maths, and then I just discovered that is serious. So when I see people that are saying they want to go and study computer science, I just tell them forget about computer science, go and study maths, and then venture into computer science. You even have better, in fact, you have a better grasp of even of the computer science, having studied math. So as a mathematics person, you have it's a sort very, the person is, I don't know, but it's not what does the person want to study? Computer science or robotics?
No, mechatronics, robotics.
Yeah, I mean, math is a very nice place to start. Just like I told you, the people who started computer science, mathematicians, artificial intelligence, mathematicians. So what's the point? So by studying math is laying a foundation for even that robotics is going to do. Seriously. Okay. And it's not even hyping it, yeah? Or you can connect the person with me. I like to take up that project.
Okay. So how do I connect him?
Okay. Yeah, I think the easiest way would be is the person on WhatsApp?
Yes, but he's not using it regularly.
Okay, so which other way?
Okay, I can get the WhatsApp number and send to him. He can know how to connect you.
Okay, good. So I'm typing my what? I mean, so the person will not. He's on the right path. I mean, what else would you want to do? Computer science? Or what?
No, physics, electronics.
Well, I mean, the person has his choice, right? But then I believe that people have left maths. The former vice chancellor of the University of Lagos, I presume you're a Nigerian, right?
Yeah.
Okay, Professor Ibidapo Obe, he studied maths first degree, and then he went to Canada and did civil engineering for master's and PhD. So how many people can move from, okay, of course you can move from physics to that too, for sure. But I mean, if you can do physics, why not maths?
He's very good at maths, but the mindset is that because I like maths, so he felt I just want to talk him into accepting the mathematics as a course.
Nah. I mean, it's a gold mine. Maybe he doesn't know. It's a serious gold mine. Seriously. Dr. Philip Iola, do you want to say something? Yeah, so please, I put my WhatsApp number there, so I mean, you can contact me. Chat.
Okay.
All right. Yes. Okay, no problem. Thank you.
Yes.
Thank you so much.
My pleasure, ma'am. Okay, Dr. Philip, you have the floor.
Yeah, well done, sir. I was just trying to ask. I attended the first quarter seminar, but up to now I've not gotten my certificate. That's just what I want to ask.
Oh, did you send a message back?
What can I do? Do you hear me?
Did you send a message we sent an email, just like now I sent our email address, blackinmaths@gmail.com. Did you reply? Did you send us an email back then? Because we do not give certificates.
I'm not sure. I'm not sure. Okay, I'm not sure.
But did you see the email today?
I'm not sure.
Okay, this is the email address now. Just send us a message. Tell us Did you attend the last webinar or you just registered?
I saw the email.
Okay,
yes.
I mean, so just send us a message that you've not got your certificate for the last webinar and this one, so you should be able to get it still.
All right, okay, I will do.
Okay.
I'll do, sir.
Right.
Thank you.
Okay,
All right.
thank you so much. Yeah.
Thank you.
Okay, so at this point, I think all questions have been taken. Once again,
sorry, sir.
Okay, please go ahead.
Sorry, I want to just briefly ask some, make
please.
some inquiry. Some time ago, I registered as a member, but I can't really actually remember how it went, whether the registration was successful or not. I think there used to be a number or something like that that they will send, but I can't remember what actually happened. So is there any way I can?
Yeah, just send a message to the same email address, blackinmathematics@gmail.com. So, and just tell us what the issues are. So you should be able to resolve it if everything is fine from your side.
Okay, all right. Thank you very much.
All right, thanks for joining. So at this point, once again, I appreciate Dr. Ralph Toom for that excellent job. I appreciate Grace Olayinka in absentia. That I appreciate everybody for attending. If we're all here and you did not attend, it wouldn't have been this nice. So thanks for coming. So the next one is going to come up in the third quarter. And then I think it's something about finance, mathematics and finances or something like that. So I know you did not want to miss that too. So we have all these things packaged so that we can see the prospect of mathematics and know that being a mathematician is one of the best things you can be. So on this note, I want to say thank you once more. If nobody else has something to say, we can as well close it. So it's nice. We actually scheduled it for 2 hours from 5 to 7 Nigerian time, but now it's 1 hour 22 minutes, which is excellent. So we can just go. Yes, we'll be expecting you, Mom Patience Evans. We'll be really expecting you. Yes. Okay, so bye. Have a great time, everybody. So please, if you want a certificate, don't forget, just write us at blackinmathematics@gmail.com and tell us what your inquiries are. Thank you very much. Thank you.
Thank you very much.
Yeah, I must
Thank you very much.
Yeah, Dr. Nick Ahion, thanks for all the preparations. Dr. Latunde,
thank you, everybody.
Very much. Thank you.
Thank you, Dr. Dansu.
Yep.
Dr. Latunde and all the organizers. Thank you.
Dr. Adejimi, thanks a lot. Dr. Kayode Oshinubi, thanks for being our host. Have a great time. See you.
Yeah, bye.
All right.
Thank you. The organizers, thank you. Thanks for the class. We appreciate it.